So now I've had a goal to have a load that is either controlled by one 555 timer or controlled by a different 555 timer. Ultimately though, me being able to switch the 555 timers with a wireless remote control. If we remove these two blue jumpers, these two 555 timers are simply wired in astable mode. This is a 10 microfarad capacitor. That's a 100 microfarad capacitor. These are all 10,000 ohm resistors to set the charging and discharging time, and a diode to get the duty cycle to about 50%. So ultimately, we have the 555 timers, again, if it weren't for these jumpers, wired in astable mode. Each one wants to output high and low, but if we ground, go to the negative supply, pin number 4 there, the reset pin, that's going to hold the output low. When the output is low, that doesn't affect the LED. The LED only lights up when it gets a high output. So thanks to these diodes, that one can provide a high output, or that one could provide a high output. Of course, if they're both high, it'll be a high output. This side of the LED will be positive, and if I remove these jumpers, you'll see that it kind of flashes for short periods of time and stays high for long periods of time. So they can both be high at the same time. And we will zoom in. My magnetic screwdriver picked up an LED. But in case, yeah, there you should be able to see the gray band there. So when the output is high, positive, close to 5 volts, then this over here is 0 volts, so current can flow through that way. Same as when this one is high. You can see the gray band there. But when this one's low, this one's high, you can see it cannot go this way because we got the gray band there. So that's the cathode. Cathode has to be more negative for current to flow through. So we can either go that way or go that way, but it cannot complete the path that way. And the LED, same thing. The long lead, the anode, is to the cathode of those two. Because its cathode is on the negative side there, whereas the anode, when the LED is lit up, is towards the positive supply. So now we come to the remote control module right here, and I have it programmed to the 3rd setting, which toggles. It either turns it on or turns it off. And so we're not turning the 555 timers, we actually reset them. So this is not actually given both of them the same signal. We'll come to why later on. But in any case, you power this. So I just have it coming from the breadboard. These are terminal blocks. You just put the wire in, screw it down. On the bottom, there's pins that go into the breadboard. So it's passed along the supply voltage. These two wires, so this one that's not going to anything is the positive. So that is always connected to positive right there. I have it to a blank spot on the breadboard though. We're not using the positive supply at all. We could power a load in between here. The white one either connects to ground or it doesn't. It's a switch. And so when it's on, it's connected to ground. When it's off, it's just disconnected. It's a dead wire basically when it's off. And so we can use that to control one of the 555 timers directly because they're sharing the same power supply. It's all coming from the breadboard. And so there you can see we got this jumper going up there. So when this is connected to ground, when the module is on, we have a pull-up resistor that allows the 555 timer to keep going when we don't have a connection to ground. But when we have a connection to ground, pin 4 is the reset pin. And so when this turns on and connects to ground, that resets the 555 timer. It holds the output low. Now, of course, we can't have this one being held low at the same time. So we have to invert what's going on. So moving on down, we have an NPN bipolar junction transistor. This is a 2N2222, but doesn't really matter which one you use. It doesn't really have any current going through it for the most part. And so we got collector on top, base in the middle, and the emitter at the bottom right there. And this jumper goes to the reset pin of the upper one right there. So when the output, or the unit is connected to ground, it's on basically, that gives a low input to the reset pin of that one, holds it off. So we can't have this one off because we want the signal coming out. When this one's off, we want this one to be able to transmit its signal. And so a low, this will be connected to ground. That holds that one off, but it keeps this transistor off. This transistor is not doing anything, so this pull-up resistor keeps this one running. And that's not the one that we got running right now. It would be flashing faster if it was. Now, if we turn this off right here, then it's no longer going to hold this one off. It's not going to be low anymore. We have a pull-up resistor. Pin 4 is going to see, 5 volts, and therefore this one's going to start blinking as it is now. We also have this jumper going to this resistor. So we had that pull-up resistor. It's holding up the voltage of that input. It's also holding up the voltage there because this is off. It's like not connected to anything anymore. It's off, so current can go to the base. This is now more positive. Before it was negative, held the transistor off. Now we have current flowing positive to negative to the base, and then base to emitter, there's ground. That's where the other negative side is. That turns this transistor on. So it's connected to ground, and it's holding that one off. So low input here holds this 555 timer off. That one can flash. When it's not low, we got that high coming from the resistor. That turns the transistor on and gives a low to the other one. So that one can flash and that one does not. It's not terribly complicated, but it may be a little confusing. Oh, also, so these are 10,000 ohm resistors, by the way. Again, we don't really need hardly any current going through this. This is actually a pretty much just a 555 timers for the most part. This is just this smoothing capacitor. So the power supply delivers voltage and current. The power supply likes when there's a relatively steady amount of current that it has to provide, especially when you limit current so you don't damage anything. And so this the power supply charges this capacitor for times that something needs a brief burst of power. Then this can power that briefly, and it will recharge itself afterwards. But in any case, it helps stabilize the voltage at the breadboard, which helps the power supply be less erratic in some circuits. I actually could probably do just fine without it in this one, but I added it just in case. So now if you have a remote control module like this, that's the antenna right there. There's something important to be aware. So you can program it. You can either press this button once, twice, or 3 times, up to 7 actually, depending on how you want to program it. But before you do, you want to press this 8 times. So I'm just going to press it once. Right now, instead of 8 times, you see we got the LED light. It's waiting for a button, and it's actually not going to do what I just tried to program it to do. It's doing what I already had it programmed to do. So let's do 1, 2, 3, 4, 5, 6, 7, 8. So see it flashing a whole bunch of times. There we go. Now we go 1. And so right now you see a slow flash. If I press the button, now we got the fast flash. As soon as I release A, then we got a slow flash. So what it's doing, it's holding the output on. It's keeping the module on, I should say, right there. Now the module is off. But we had to press it 8 times. 8 there to, clear it. 1, 2, 3. We're going to go back to what I want now. And so I want one setting to be A, and then the other one to be B. And then so A should be turning it on, the module there, and then B turning the module off. Again, it's not turning the 555 timers on and off. It's just resetting one, which keeps it low, or it's resetting the other one, keeping that one low, letting the other one operate normally, as I mentioned before. So, in any case, hopefully that all made sense. It's actually not too terribly difficult, but probably confusing if you've never seen a circuit like this before. So, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.